Good morning once again for this series of training workshops through which we are collaborating the Ministry of Agriculture and Irrigation, trying to empower participants on the use of Earth observation, especially the Africa platforms, to monitor several phenomena. Last week, it was just introduction on the Africa platforms in general, and today we'll be focusing on agriculture and the food security, how we can use the Africa platform to inform some agricultural practices in Somalia and in Africa in general. And of course, I recognize the contribution of Kenneth Mobeya, who is a active movement lead. And my name is Joseph Tuyishimire, and I'll be facilitating this workshop. So once again, I won't take much time on the Africa. So a free access, a free interface that will be able to monitor several phenomena across the continent for free using our floating data sets. They are already processed, and you just connect it to the necessary part. And of course, we try to empower governments in the use of your data sets and to inform some actions related to climate mitigation and also contributing to the food security and its SDGs in general. So the work was possible thanks to the collaboration with the several institutions across the continent. And of course, our data are hosted in Africa, South Africa on the AWS server. Actually, we have around 5 petabytes of analysis ready data sets. And we have several products, but today we'll be focusing on the use of GeoMads, the crop land extent, the regional cover, and the climatology, just to inform of vegetation situation in Somalia, but also try to understand the trends in space anytime. And we are using an open data cube technology for which you can run the analysis just for all region rather than running it at continental level. And of course, we are contributing to SDGs, and today we'll be focusing on food security, SDG 2, zero hunger. And we have a lot of tools and what that were developed for any purpose, and they are grouped by themes, and the continental products and services and tools that can be adapted to local situation. So as I said, those are some of our products, as Kenneth said last time, and the fractional cover, the crop plant extent could help us to inform actually food security and of course contributing to solving problems related to agriculture and food security across the continent. So if you go to the food security, this is the example whereby we can use some container products just to understand visually using RGB images how the trends in vegetation cover evolves over time, but also we can use vegetation index. This shows the NDVI, trying to understand the vegetation cover. But we can also use the enhanced vegetation index just to even compare several years from the start of the season. That's why people are planting seeds. The peak of the season, while the plants are in plain growth, it means that when the NDVI is at the peak, and also in the season where people are harvesting the plant. If those we see some shift, I mean that either there have been a kind of crop rotation, but also the shift in seasonal variability. So we are aware that people are familiar with different interfaces, and that's why we try to diversify the way to access our data sets. And here the map, I'll be showing how it works. It's very easy very friendly. You can do some exploration, even do some machine detection, even share some uh, ex some dynamic links among the group. The sandbox is a robust cloud computing interface of which you can run or statistical analysis and export results in terms of maps, tables, graphs. Even you can even export either results in GeoTIFF format. Even raw data could be exported to. But also can the classic softwares like QGIS or ArcGIS then access directly to data sets and work from your PC. Of course, capacity building is a very important aspect of our work. That's why we have put in place a learning platform. When you log on to learn.southafrica.org, you can access to approximately 10 modules, very detailed. You can do it them at your own pace, and you get a certificate as rewards at the end. So I was talking about the Africa map and how it works. And if I give you an example of a map, so if you go to the browser, we can even go together if we don't mind. If you go to the browser, you type the Africa maps dot the Africa dot Africa. I share the link in the chat. You have access to already to this interactive interface, and you can change settings. You can change the background using the map you choose. I prefer this one with uh, a high resolution image in the background, but also the boundaries of the countries. You can change the languages. It's available in French and English. And then we can zoom to Somalia. And yesterday I was looking at the river, at Shebele River, and zoom out at this area. We can start. We can explore data set you have in the interface. I was telling you that we have data sets which are for the Africa, just that were generated by our team, our sales team. Those consist of the coastal the coastal service for the monitoring the coastal erosion, and the surface water, which is not the topic of today, but for agriculture we have the crop land extent, and we can add it to the map, and you can see that it can show us the mask of all cropped areas around this river. And from here, you can either try to understand, change the legend, maybe put the probability of cropping. This is aquatic area, and you only see on the legend, you can see that this area has a high probability of cropping, and this is possible because due to the irrigation, because near the river. And I can say Abu Quran. I've shared the link with the Africa map. Yvette, once again, thank you. And from this map, we can share a link, and this link is interactive. You can click on it whenever you want, and then you can get the full details as myself am viewing everything from here. And also, as you see, for vegetation, we can also use some images and use some proxies with the geomedians. Those are cloud-free mosaics covering the whole continent. And for these mosaics, you can go to the geomedians. Those images were processed by the Africa team, and mosaics were created at continental level. And what you can do, you can load, let's say you load the geomedian from the geomad from Sentinel-2. That's Sentinel-2 starts from in our database starts from 2017 to nowadays. While the run starts from 1984 to nowadays. And then we can select a proxy that's about to understand the crop extent. Here we have the NDVI as a proxy. You can see that those areas with the agricultural areas have a higher NDVI, and you see special rivers, we have a higher NDVI. It means that the probability of cropping is higher. And this is, you can choose one date. This is for 2024, but you can choose maybe 2017, and also we can do a comparison. You can compare 2 years. So now we can compare 2017, and you can compare it with, let's say, 2024. And then this was 2017, this was 2024, 2017, 2024. You can see that 2024 looks greener than 2017. This is a good indicator that the average, the median NDVI in 2024 is higher than the one in 2017. That's the crop health, even the yield, the production in general has been higher in this area in 24 compared to 2017. This could be confirmed by people on the field, or you can do some visits. So you can create a story map. You can capture the scene, and maybe you can put NDVI, Shebele River, and you can put a text here, 2024 greener than 2020, 2017. And then I can save. You can see this is I can also go back if I want. I can go back and edit, and then I can save once again. Then I can share the link with you so that you can view it the same way I've been doing it. We can do more depending upon what to achieve, but today we are focusing on agriculture and food security. And also, we can have several ways to explore data sets, but let's go back to our presentation. This was the map, how it works, how it can to explore some agricultural and crop activities. And that was the example of the crop probability of cropping that was overlaid with the water observation from space. It's a service that we part to mask out aquatic areas in a given area, and then you can still share the link with the team. And if you go to a sandbox, which is based on Python coding, it's a very robust interface, and just confirming if each of you has created a sandbox account. Is that true? Hassan, is that true? Everyone has the sandbox account? Mohammed?
No, I don't think so. So maybe tell the participants right now to just
Oh,
register.
Oh, great. So if
Yeah.
not, so before I introduce it, the capability of the sandbox, I have a time also to create a sandbox account for everyone. No problem. It's a straightforward process. And within this sandbox, you just create your account, you activate it, then you have access to different libraries, different folders. The first one is getting started with the sandbox, that's introducing everyone to the principles of Python coding, even for beginners. You don't have to be a programmer. Myself, I'm not a very good programmer, but you need to be able to understand some basics of geography, like your location, some proxies for the phenomena going to monitor, and also the time scale uh, of analysis. This is the beginner's guide with the data sets, how they are all processed over time, the frequency code that will generate some indices, and to do some key analysis, build examples, some code we think may be frequently needed for the real life phenomena, and also these cases that contains the codes that were developed by users, and once validated, you are willing to share them with the public um, for lab use. And if we go into the sandbox, we have tools are grouped with the themes, and that's where we can see the crop plant extent, the crop health using NDVI, the crop health using DVI, the tools for the forecasting of vegetation condition, fractional cover, and several phenology, vegetation anomaly, and so on. Those could be useful tool that could help us to monitor agriculture and vegetation in general. And for example, for the crop health tool, uh, we can we can compare several plots of a given area, but today we'll be focusing on these many tools: the crop health, the crop extent map, as shown in the Africa map, and also the crop plant monthly vegetation and the condition using NDVI, and lastly, the crop phenology using both NDVI, EVI, and also the radar vegetation index, which we call RVI. And each tool was very documented, a short description, steps for to run the analysis, the location in a folder, input data, and also related SDG. And this is a very structured using the sandbox. And now we know we can locate um, each notebook we'll be using today. And this is an example where you can try to understand the vegetation anomaly over time, but also we can understand the phenology being using either the optical or radar sensor, and try to understand the peak of NDVI, the amplitude, and the rate of growth, and so on. But also we can develop some kind of predictive models for the vegetation condition uh, using the appropriate model. And before we start, I have my sandbox open, but what you can do before we start, you can go to into your browser, and you can type you can go to the Africa sandbox. You just type the sandbox uh, you can type the sandbox dot d2f dot Africa. I'm going to share the link in the chat for you to start creating the account. I'll share the link in the chat. You go to the sandbox dot d2f dot Africa. Let's go together so that everyone could get the account. Sorry for the page. I didn't want to get it. And I hope everyone can see my screen. Let me go to our full screen. I want to see what's necessary. So when you go to this page, if you have already created your account, you just log in. And if not, you go to sign up. I hope we are working together to put the account. Please put your thumb up if you are able working on the creation of the sandbox account, so they could know how to support everyone on the call. Mohammed, am I audible enough? Hassan, can you hear me?
But still trying it.
Okay, thank you. Actually, it's way of showing you how to create to create a sandbox account. You put your given name, your family name. You set the gender, the age category, and you put your email, and you put your phone number with the country code. This is very important because you get activation codes via your phone and your email. You put a password and you confirm your password. You can put organization details, the type of organization, if it's academic, government, NGO, private, or NGO, and you put some thematic areas of interest. Here you can choose many, not only one. You can choose several areas. You put your shift. You can choose as many as possible. Then you can put your location, being at national level, at continental level, the time frame, whatever time frame you choose that reflects the work, and also how did you hear about this? If you had a previously existing sandbox account that was not operational during the upgrades or the interface, then you can say I am an existing user. Then you can create your account. You'll get an activation code within your email, and then you can from there you can log in and start enjoying the capacities of this sandbox for free, and uh, you get notification whenever some new products are created. So if we go back to our sandbox, we can go inside our sandbox. As I said, we can get a, a notebook called crop health, which is under the folder called Leod examples. And from this notebook, which is also equally available on our GitHub repository, what you can do, we can locate a study area, and this was Bure area, and the location there, and for the date of August 2025. And notebook uses Sentinel-2 data sets to measure plant health over time, to identify changes. And we use the NDVI, and of course, it's just comparing, it's combining the roid and infrared radiation. And again, you can see this tool could help us to compare several plots within one field to see if their performance is the same. And if you try to compare all the plots, you can see although the zero trends remain the same, but for some years, the performance, the NDVI peak have not been the same, especially, and this you can see if you compare to this in red, the red curve, you can see that the NDVI was lower compared to the green and blue spectral signatures. And this is a good information why those plots within one field not perform the same way in our area of interest. First of all, this should be due to the change in agricultural practices, like inputs in terms of seeds, fertilizers, and so on. But also there should be a kind of climatic stress, water shortage, for even some natural disaster, but also it could be kind of crop disease that have affected the plants. And once again, this should be cross-checked. But also in Africa, most of the countries have a crop rotation system. Maybe also this should be justify the change of the curve. But for our area also, we could understand the phenology. This, when I tried around the Shebele River, I tried to write the notebook that could choose the NDVI to understand the phenology of plants over time. And this is combining the crop mask product and also the senior data set just to understand the time series of NDVI phenology over time. And the notebook is accessible also via GitHub repository. And we were working on the time scale from January 2023 to December 2024. And of course, we should always be able to define our area of interest either by defining latitude, the longitude, and the buffer, or even we can load a polygon defining the boundaries of our study area. And once again, if we try to use the zonal mean of vegetation time series using NDVI, you can see the curve is not continuous. And this was due especially to the fact that some of the images were cloudy and then they were left out during our analysis. But also we have another step trying to smooth our curve and be able to separate years 23 and 24. And you can see that the peak of the season was sometime in August and September. And you could see it's kind of coming over time, although you can see that the NDVI was higher in 2024 compared to 2023 for our study area. And this we can also compare year by year. Here we compare 2023 and 2024. You can see that the start of the season is the same, But when you go to the peak of the season, uh, the season was not the same. For 2024, it's just sometime in January. We can see sometime in June for 2023, and even the peaks of the season was shifting the same for the end of the season. This is it's a kind of seasonal variability or crop rotation. Once again, this is something to be validated on the field. And also can try to understand more statistics, the when the NDVI was at the peak, how was the NDVI at the start of the season, how was it at the end of the season, what's the amplitude of the rate of growth, rate of senescence, and so on, just to understand the trends over time. So we can also use the radar sensor, which is very good because it can penetrate the clouds. And this uses mostly what you call radar vegetation index, RVI. And of course, we'll be working on cropped areas, and the location remains the same around the Shiberi River. And we can plot some false colors of images that was especially for 2023, and you can see how it has been changing over time. But mostly, if we put the zonal time series, you can see how the RVI or the vegetation greenness have been evolving over time. Try to show this November as the peak, and the same we can try to separate year by year, and you can see the peak in the same, while you can change from one year to another. The same could help us to have some phenological analysis using some statistics, and of course, when you compare the results from optical sensor and from the radar sensor, they are almost the same, showing a kind of change in the time of planting when the NDVI is at the peak, but also the end of the season also is not the same, almost 1 month interval. And once again, all the two platforms are good. The radar is better because we're able to overcome the clouds, but we are relying on Sentinel-1 data, which are free, but very limited spatial coverage, but also the time series are not that high. So there are a lot of stuff. This was in Katunuare, and we can try to understand the trend in vegetation health, but also we can compare them with the rainfall, just a kind of checking what is the effect of the rainfall on the vegetation trends over time, as you can see. And we can also compare, combine the vegetation productivity in general, the anomalies with the rainfall and related anomalies, and of course to better understand the phenology of our plants over time. And this is also very key when assessing the trend in plants. And also we can develop some regulative models that could even include exogenous variables to develop a vegetation forecasting model. And when you validate it, you can see how the trends, the predictions are more or less matching the validation. data sets over time. This was the case of Bole in Ethiopia, and I think this has several similarities with the region in terms of climate. And now we are working with the agreement regional center in Niger to use machine learning for the development of a crop type mapping workflow, where we try to understand the the trends in each crop, and also try to estimate the hectares, even try to estimate the yield over time. This is a machine learning, it's called machine learning approach, and also the classification module, of course, will combine both the high quality earth observation and field validation data for both the predictions, training of the model, even the validation. And initially, we're able to understand the some key crops in the area, groundnut, maize, I don't know how to call it, and niebe, and those local plants in Niger. And of course, we try to come up with some estimation of area. And once you're able to estimate the area, and you know what was the peak in NDVI, and we can try to predict or to estimate the yield over time. Of course, you can also use the platform to understand the 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 rangeland health as you're cooperating with the NRT in Kenya. And this, able to understand the vegetation or the phenology or the grass over time, and this should be able to inform some policies related to the rangeland management across 22 conservancies in which the Northern Rangeland Trust is operating in Kenya. This was achieved through the combination of the modified soil adjusted vegetation index, the normal difference vegetation index, and the enhanced vegetation index. And you can get a phenology map to inform the management of those conservancies, but also to avoid human wildlife conflicts, even conflicts among communities. I think this should be also feasible for Somalia, because I was reading that they have a lot of rangelands at national level. If you are able to enter into the sandbox, initially you were creating a sandbox account. As I said, when you enter into the sandbox, please ignore all these folders in my sandbox account. We have many folders, which mostly consist of, first of all, I can show you the landing pages, which is very important. When you open the sandbox account, let me just go to the full screen mode, able to see it very easily. When you open the sandbox, you see in this landing page that shows you a kind of welcoming note, and try to give you a brief overview how we can switch from the sandbox to our GitHub repository, how you can download and upload notebooks, but also how you can do some backup with the Google Drive. And down here, there is some categorization. You can, our notebooks are summarized by SDGs, because we think it's a good way of informing several priorities that aim at achieving SDGs. So, and under each goal, we try to put some key tools we think can contribute. Now we are talking about the goal two. This is zero hunger, and then we have all those notebooks you see here. For each indicator and sub-indicator, we have developed some key tools, and that will part to inform the goal. Once again, we try to contribute to each notebook, to each SDG, which is achievable using fully all-party Earth observation data sets and geospatial technologies in general. And also, we can see on the right page, our notebooks are grouped by themes. Someone maybe not aware about SDGs, but he want to know what are tools help me to monitor crops and the vegetation in general. That's why you have these themes, agriculture and vegetation, and through it you can see from the cropland extent, and you can go crop health, vegetation fractional cover, and NDV anomaly, animation, hematology, phenology, and so on. So you from here, maybe you can click. When you click, you go directly to the related notebook, and of course, it's taking longer because it is heavy. And each notebook is what does the notebook? It has a title and stuff I want to show after. But also have some key folders, as I said initially. The first one is beginner's guide. It has some basics of Python coding on how it can work with the Jupyter notebooks, and it's very basic but very important. We have to understand how the sandbox works, or if you want to customize the what's there. But also have the data sets. This notebook is showing the number of data sets that were developed or that are accessible via the Africa platforms, and all the details on their specifications, capabilities, even limitations. And also the third notebook is the frequent used code. This shows us how to do some preliminary analysis, like calculate band indices, how to do some animations, how to generate geomedians, how to segment some images, how also to integrate several data sets, how to do the tide modeling. Someone was asking about the something related to oceanography, and this should be a key model to support it. And also we have what you call real examples. Under this folder, we have several notebooks that were developed just to help people to go directly to the analysis. And today, we'll be using this crop health, using both EVI and then DVI. We'll be dealing with the crop phenology, using optical and using the radar sensor. And I think that will be enough. And also we have what you call the supplementary data. Those are data sets what from others or by the Africa team, just to be rolled directly during the analysis. They are linked to each of the notebook in our sandbox, And tools, some important tools we are using in the Africa on the Africa platforms, and also uh, uh, we have also the use cases through which we are sharing some notes, some codes, even results for people who judge better to share to the community of users. Of course, they should be first of all checked and validated by the Africa Science team. And if we try to go into the notebook, you go to the real-world examples. We have real-world examples. We have this notebook called crop health. To make sure that you won't lose the track while you're doing analysis, you can go to the right page and duplicate the notebook, and then after you can name it. For me, I've renamed it Somalia. Just make sure I'm training people in Somalia. And from this notebook, what I can do, it is open from here. Each notebook is very well detailed. It has a title, the input data. Here you'll be using this net2 data sets. We have the keywords. It has the background. This paper to scout disease damage, but also to investigate the reason behind the poor performance of a given a plant in an area. And this is using the NDVI, and you can compare several NDVI over years or between plots. Of course, the description steps, you create time series over crop plants, you set multiple area for comparison, you create a graph, and also you can interpret the results. So first of all, we'll be able to roll the packages and applications we'll be using, especially we are loading crop health data and running the crop health analysis. And all those, in addition to connecting to the Africa data keep, we are loading the packages. The other part is to know the time scale for your analysis. That's where we could be able to either put your ear here, but also you should always understand the spatial extents for your analysis. That's why you can use latitude, longitude, even the buffer. And most importantly, sometimes data may not be available for a given area. That's why this Map Explorer is a very important tool just to investigate if the data sets are available for a given area. Like working in Somalia, for example, you can zoom to Somalia for a given area, maybe for this area, just on a simple click. It's just on a click, we can open, not open of the directory on. If you go to this Somalia, okay, now it is showing up with a delay. Or for our area, you can see that all those the images are available for each of the dates. And this is very important because if we run the analysis for an area without data, this should cause some issues. And If I go back into our sandbox, let me go back to our full screen, and we can choose any given area. But for me, I preferred to work on this part of Somalia. I'll share the coordinates in the chart, and with the date of 1st August 2025, and then you can raw data sets. That should be Sentinel-2, and especially we raw data sets with a good quality of less than 50% cloud cover. Then you'll be able to run the function. So what you can do to run our analysis, we can go to our kernel, and we can stay and start kernel and clear all the outputs. It means that you're kind of starting our analysis, and you could see that each cell is empty. There's no number on this side, and then you can start one by one, and each cell, the output of one cell should serve as input for the cell. Now we are loading the packages and the functions, and you see that there is one that is the first cell we are running. We can go to the second cell, defining the time scale and the spatial extent, and this is being run. And you can also run the data sets. This may take longer because it is running, assessing the cloud cover for each image, and trying to capture, to keep only images that meet the condition of having a cloud cover which is less than 50% of cloud cover coverage. And while running this, once the images are loaded, now they are loaded. You see now we have the third cell, and what you can do here, we can run our application. When you run application, you can see this is our study area, and we can use this button to draw a polygon. That could be part. If when you draw a polygon, it draws automatically a spectral signature on the other side. Let's choose some several plots, like a 4. You can see that the extent of the spectral signatures is similar. The trend seems the same over time. And so, if, for example, if you see for this orange polygon, the performance seems a little bit lower compared to others. That's why I should go to feed, just go check what happened. So I did this using both the EV and DVI, but also we can understand the phenology of a given area. Once again, the notebook is well defined. The phenology, all details are here, and the description of using the NDVI and EVI, and also all the steps are well documented in the notebook. Once again, you can go to the kernel and start and run one by one, or you can start the kernel and run cells that each cell should be executed one after one from the first to the last cell. So for the sake of time and also of internet, I've run this analysis before, and we should be able to load several packages and functions as the Africa have developed, and try to access the data key to deal with both table and image data, and with the data cube, define geometry, and produce some plots, define area, calculate indices, display maps, and so on. So we'll be using a function called vegetation phenology. Of course, we define our study area using the approach I've shown before, but also we can upload a shell file denoting the boundaries of a study area. Then, of course, we define the time range over time. And of course, you can run the specify the study area, but also can show it on the map. This is the area near Siberia River, just showing the notebook, and then you can enroll the crop mask, as I was saying, then adjust our analysis on only croplands, and then these are examples of randomly chosen RGB images, and you can see some are cloudy, like this of 24th of April 2023, one of 12 August 2023, but at least the one of 9 January 2023 and 20 December 2023 are clear enough. That's why the geomaps are better, just they're kind of factoring all those clear and cloudy images. Then those are formulas calculate our indices, both NDVI, combining near infrared and infrared radiations, and this is the EVI combining both near infrared, red, and blue radiations. We can plot the NDVI over time with the zonal statistics, and you can see that they are not continuous. Those images that were already clouds over time, and then you can smooth our curve until you get a continuous time series with clear separation between years, but also showing the peak, even the lowest NDVI over time of analysis. Also, you can try to understand the phenology at the start of the season, to the season, and the season, the value for each time scale, and the other statistics like length of the season in days, amplitude, rate of greening, and also rate of senescence. And of course, we can come up with a comparison between years. This was interpreted, and then of course those phenology aspects try to understand the concentration of NDVI, and the key statistical analysis also can be achieved. And of course, for this, this could be done also for radar sensor. As I said, radar sensor which could penetrate clouds, and although this is very limited in our database because we are depending on something one with a small spatial coverage, but also a limited time series. And of course, the approach remains the same, except that we are loading radar data sets and they're using radar vegetation index function. I use the same study area just to make sure that they don't confuse, mess up the stuff. And so for radar, we wrote our images because we don't have anything to worry, because clouds are no longer an issue. And of course, we working upon the area of interest, activate the area. We have almost 56 images, radar images for 2023 and 2024 for analysis. We can plot the true color and do some zonal statistics to understand the trend in radar vegetation index. And of course, we can smooth and do interpolation of our time series, and of course come up with the comparison uh, between years, but also can compare several years. I've chosen two just to run them quickly, but you can go beyond two. And of course, the latest general statistics, crop statistics could be generated as well using the LRVI. So we have several capabilities using the Africa platforms, and the most important that I can share with you the Digital Africa user guide. First of all, that's showing you what platforms we have, how they work, but also what products we have and what are their strengths, how they are processed, what are their strengths and limitations in doing our analysis. So this is for the product. I share it in the chat. This is for the platforms, how to access them and how they work. I share it also in the chat. And also we have our GitHub repository. When you go to the Africa GitHub repository, all the folders, the main folders I talked about, let me go back to full screen. All the folders I talked about are fully accessible via our GitHub repository for those who are familiar with the Python coding. And of course, once again, I'm going to share this in the chat that you could have access to all this and enjoy freely our datasets and service. Once again, if I go to our presentation, we have a lot of tutorials available on our social medias, especially on our YouTube library, our YouTube channel. Then even there is one on how you can monitor the crop health, try to understand the drought, the soil moisture, and we have almost 1,000 videos, tutorials showing how we can use our platforms and service to monitor several phenomena, including the crops. But among our courses, we also have one dedicated to agriculture and food security that was even upgraded sometime in June this year, and also in collaboration with the DIWASA, with the IMI, we tried to, through the DIWASA project, to develop a module on the integration of water and crop products to inform several activities, related to food security in Africa. Then this is our website. You can have a look at it. Each Wednesday we are meeting to discuss several products in the Africa platforms. This is always 11 GMT. It means that should be 2 p.m. at the hour of Somalia. Then you can join us if you give any French and English over time. We thank our partners, including the Somalia Statistics and the Ministry of Agriculture and Irrigation for the timely support and also the making this happen. And of course, for your feedback, please scan the QR code to get access to the form for which you can give your comments and the feedback. And on this, I can say thank you. And for discussion and exchange comments, questions, you are the most welcome. Mohammed, over to you, sir.
Thank you very much for your good class. And I would like others to comment, to ask questions to to Joseph. And if I start my question, how I can get real-time data to your platforms, and we have seen your data, but how can we get it in the real time? For example, if I want last week or maybe this week data on my area of interest, how can I get this real time